Welcome back to Daily Dose of Space. Black holes are often described as the end of something, the final collapse of a massive star, the last stage of stellar evolution. But when astronomers started looking deep into the early universe, they realized something unsettling. Black holes didn't wait. They appeared astonishingly early, when the universe itself was still young, unfinished, and barely recognizable. Some of them were already enormous, growing faster than our best theories say should be possible. Today, we're not talking about black holes as cosmic leftovers. We're talking about the first black holes in the universe, and why their existence still challenges everything we think we know about how the cosmos began. A young and unstable universe. To understand the first black holes, we have to forget the universe we see today. The early universe was smaller, denser, and far more chaotic. Space itself was expanding rapidly. Matter was unevenly distributed, and large-scale structure was only beginning to emerge. There were no galaxies as we know them, no spiral arms, no long-lived stars, just vast clouds of hydrogen and helium, slowly responding to gravity. Dark matter played a crucial role, forming invisible scaffolding that guided where matter would eventually collect. But even with this structure in place, forming anything compact was difficult. Cooling was inefficient. Gas resisted collapse. Everything took time, which is why black holes shouldn't have existed yet. The observational shock. The problem began when astronomers discovered extremely distant quasars. Quasars are among the brightest objects in the universe, powered by supermassive black holes actively consuming matter. As gas falls inward, it heats up and releases enormous amounts of energy. Some quasars we observe today formed when the universe was less than 1 billion years old. That alone is not strange. What is strange is what powers them. These quasars are driven by black holes with masses of hundreds of millions or even billions of suns. According to standard growth models, there simply wasn't enough time for black holes to grow that large. Even under ideal conditions, growth is slow. Radiation pushes matter away. Accretion happens in bursts, not continuously. Any interruption ruins the math. And yet, the black holes are there. This is not a single anomaly. The more we look, the more examples we find, which suggests the early universe was unusually good at making black holes. The first stars as seeds. The most conservative explanation starts with the first stars. The earliest stars, known as population 3 stars, were massive and short-lived. They formed from pristine gas, with no heavy elements to regulate fusion or cooling. As a result, these stars burned hotter, brighter, and faster than modern stars. Many of them likely collapsed directly into black holes at the end of their lives. These stellar remnants would have been larger than typical black holes today, perhaps tens or hundreds of solar masses. But even with that head start, the problem remains. Growing from hundreds of solar masses to billions in less than 1 billion years requires near-perfect conditions. Continuous feeding, no interruptions, no feedback strong enough to stop accretion. It's theoretically possible, but it's not satisfying. Direct collapse, black holes without stars. This is where the story becomes more radical. Some researchers propose that the first massive black holes never formed from stars at all. In certain regions of the early universe, enormous clouds of gas may have collapsed directly into black holes without fragmenting or igniting fusion. No stars, no supernovae, just collapse. These direct collapse black holes could begin life with masses of tens or even hundreds of thousands of suns. With such a massive starting point, reaching supermassive scales becomes far more realistic. The conditions required for this process are rare. Gas must remain hot enough to avoid fragmenting, yet dense enough to collapse. External radiation may need to suppress star formation entirely, but simulations show that under the right circumstances, it can happen. If even a small number of these objects formed, they could explain the earliest quasars we observe today. Black holes before galaxies. One of the most unsettling implications of early black hole formation is their role in shaping galaxies. In the modern universe, nearly every large galaxy contains a supermassive black hole at its center. Traditionally, we assume galaxies formed first and black holes grew within them. But in the early universe, the timeline may have been reversed. If massive black holes formed early, they would act as gravitational anchors, pulling gas inward and triggering star formation around themselves. Entire galaxies could assemble around a central black hole. Instead of galaxies creating black holes may have created galaxies. This idea is still debated, but it fits surprisingly well with what we observe. Primordial black holes and deeper questions. Some theories push even further back. There are ideas suggesting that black holes could form directly from density fluctuations in the very early universe, even before the first stars existed. These hypothetical objects are known as primordial black holes. They remain unconfirmed, but if they exist, they could reshape our understanding of dark matter, structure formation, and the earliest moments after the Big Bang. In that scenario, black holes wouldn't be products of cosmic evolution. They would be part of the universe's initial conditions. What we can and can't observe. Despite major advances, direct evidence remains elusive. We cannot yet see the birth of the first black holes. We infer their existence from quasars, galaxy dynamics, and simulations. New instruments, like the James Webb Space Telescope, are beginning to probe closer to the era when the first black holes formed. Gravitational wave detectors may one day capture mergers involving ancient black holes. Each new observation narrows the possibilities. But the origin of the first black holes remains one of the biggest open questions in cosmology. The first black holes appeared too early, grew too fast, and influenced too much to be ignored. They may have shaped galaxies before stars fully formed. They may have existed before light filled the universe. They may even trace back to the universe's earliest moments. Black holes are no longer just cosmic endings. They may have been part of the beginning. And the deeper we look into the early universe, the more it seems that the darkest objects arrived first.